A fair die is rolled twice with outcomes x at the first roll and y for the second roll. And now we are asked to find the moment generating function as the sum of these two random variables. So let's start by defining, we can put, define x plus, let's define w as the sum of x plus as y, which is this sum, and then find the sum of the MGF of w. In fact, we are actually asked to find this in this form. Well, it's identical, but what we can do is do the following. If we want to see this notation, and that is, can do the, it's an unnecessary complication, but bear with me. This is then by definition the expectation of e to the w, which is the expectation of x plus y. I mean, this is just to say. Okay, so these are now identical. Sorry, these are independent rolls, right? So we can then use independence and the rules of exponentials to separate out this ETX, sorry, the expectation over ETX multiplied by the expectation of y, like that. And then we can evaluate these terms separately, but they will be identical because they have the same distribution as well. So let's just find the expectation over this transformed x, which is, by transform I mean by Lotus. So we write this then as the sum over the support of all these roll die, I mean these die values that we can get, but then by Lotus we can then view this term here as the transformation of the value x. Okay. Now this is the right, and we multiply it, sorry, by the PDF of this these values. So it's 1 divided by 6 because each outcomes have equal chance of happening. Continuing on, and this is in fact the expectation. We are also allowed to write this as an unsimplified finite sum form. So we're not going to do anything else with this. We're just going to write it out as we wrote it there below, and we have now 2 of these expectations. So the MGF of the sum, which is w, is in fact this term here.